All right, hello all you wonderful people. Let's go ahead and get started with today. We got a bit of a shorter lesson today because it's a half a day at our school. So half a day, shorter lessons, it makes sense. So I'm gonna go ahead and do our usual review. So yesterday we were simplifying complex numbers. So we're just gonna do a few of these and move on to what we're doing today, which is gonna be a pretty short lesson on its own. So it kind of worked out, everything just works out kind of fine today. So if we want to simplify a radical, it's not really that different than if you were to just simplify, say, the square root of 64. You can do what we did yesterday and factor it. So when you factor it, and I'm going to do this a little bit different than I did yesterday, because after that lesson yesterday, I thought, you know, there might be an easier way to do this. And sure enough, I thought of not really an easier way, but a more intuitive way. So what I'm going to do is I am going to go 8 times 8, because that's how you would normally break down 64 is 8 times 8. But I'm going to do something, the different thing I'm going to do today is I am going to put the -1 as the last number. Now, I don't think this confused anybody, but I think it makes a lot more sense when you can see that there's a negative number in there and it's the last number. So this way, when we are trying to take things out of the radical, remember, you need 2 of them for a square root. So I have 2 8s, and when I take it out, there is only going to be a single 8. So I end up with something that looks like this, 8 to the root of -1. But remember, we can also simplify root of -1, because the root of -1, as, where did that slide go? Oh, the definition of I is the square root of -1. So we're going to use that and remove this and replace it with I. So 8 and then this root -1, we're just going to turn that into I. So we put that little cursive I on there because it's a special variable. And special variable means that it does mean the same thing most of the time. So most of the time you see the I, it means imaginary number. Excuse me. And there we go, we're done with that one. And if you remember from the homework yesterday, so I looked over the packet, and yeah, there are going to be a couple of these where there will be a number already on the outside of the radical. So if we factor this down, so again, we just need 2 numbers that multiply to 100. So first thing I'm going to do is I'm going to ignore the negative for now. And this is 5 times the square root. I'm going to make the square root a little bit smaller. And I'm going to split these 2 apart, because remember, that is one of the things you can do when simplifying radicals is you can kind of break the elements into their own radical. So square root of 100 times square root of -1. So it's just a little bit different than the one I did here, because the -1 is combined with this. But again, you can just split it apart. That's another one of the properties of radicals that we discussed earlier. So nothing really different there. And again, there's always different ways. You can always play with these different ways, see which one works best for you. But now I can go ahead and just evaluate each of these radicals. So 5 times root of, actually I don't need the root. I can evaluate the square root of 100. So that's going to be 10. And here I have the root of 1, which again, I'm going to evaluate that root so that I have I instead of the -1 root. And I'm just going to put all these back together now. So 5 times 10 is going to be 50 times I. So I just stick that on the end and we are done. So we managed to evaluate everything so that none of the radicals are left over. And that's it for this slide. I'm going to go ahead and move on to the next one. Now, as you're writing these down, you might notice that some of them are not perfect squares. Like on the last slide, we had 64, which is a square number, and we had 100, which is a square number. but 32 is not a square number. There are no two numbers that are the same that I can multiply to get 32. So we're gonna have to factor this again. So you can use a factor tree like we have done in the past. And remember, there's also two ways to do this as well. You can do the first thing we did and look for square numbers, which is what I'm gonna do. So I'm gonna think of a set of factors that I can multiply to get 32, where one of them is a square number. So we could try something like 4 times 8, which works actually. I wasn't expecting that, but 4 is a square number. But we want the biggest square number we can get. So we could try another set like 2 and 16. So 2 and 16 works, and it works better because 16 is a much larger square number. So that's what I'm going to do. 2 times 16. For now, I'm just going to ignore the negative. So I can go ahead and take the square root of 16 and go ahead and I'm going to move it over here. So square root of 16 times 2 times I. Now again, we can go through this, or we can make all of them with their own radicals. But I think this is a little bit easier because I just draw one radical, and that kind of takes care of everything all at once. So I'm going to take the square root of 16, which is 4. Oops, I'm getting a little bit ahead of myself. This should be -1. Got a little bit ahead of myself there. I mean, I already know that there's gonna be an I value in there. But right now, we are just trying to get that negative off of these numbers so that they are gonna be easier to factor. So in this case here, now I can take that value out as I. So I'm gonna take that variable I out, and you notice that we leave something in the radical. So I'm not able to take all the numbers out of the radical. I am stuck with that in there. We can't take that 2 out because 2 is not a square number. So it just sort of stays in there and we leave it like that. And you can kind of think of it like in division, there's remainders. So if you can't divide a number nicely, a lot of times you just have to take it out and leave the remainder in there. And that's number 10 completely simplified. We can't do anything else with it, so let's go ahead and move on to number 12. Now for this one, I'm gonna completely factor it. I'm gonna take the prime factorization all the way. And again, I'm just gonna ignore the negative for now. So 12 is 2 times 6, and 6 is 2 times 3. Now again, you could do what we did over here and break it into square numbers, and to do that you would have been done something like 4 times 3. But again, this is just another way of doing it. I can see that I have a pair of 2's, so that means that a set of 2's come out. Now I also have -1 multiplied in there. Like I said, I was going to just ignore it, but here I can see all of my factors here. So this -1, we can take the square root of it because that -1 is under the radical. So I'm going to take that out as well as I. And I'm going to see what I have left in there. I have 3, which again, I cannot take that out. So it just stays in there. And simplifying radicals is something we've already done before. If you're not sure, you can always go back and click on my video of multiplying radicals. And I could probably tell you what day that was, the 24th. So on the YouTube video, you would just go to 8/24 video. And there you go. If you ever miss a lesson, you can always just go back and look at them. I want to put end cards and be like, you can just watch the video right here. But that's going to be a bit of work. And right now, I don't have that many videos. I only have like 50, not even 15, like 10 videos. Anyway, we're done with this one now. So we're going to go into what we're starting today. I'll start from the beginning. Well, I usually put the slide all the way back, but I guess I didn't reset it since the last time I was here. So for today, the lesson will be, you should be able to express roots of negative numbers in terms of the imaginary number. And express imaginaries as b times I, and that should be a cursive b, and complex numbers such as a plus b times I, which if you remember from the last two slides, it's just complex number just means there is a real part and an imaginary part. So these complex numbers are part real, part imaginary. Students should also be familiar with the rules of how to subtract and add complex numbers and express them in the correct format. So, you know, just as an example, if you put something like 5i plus 3, this is the kind of answer I usually get into a little bit of a tussle with students about, and that is, but it's technically right. I mean, all the stuff is there, and then I have to kind of be like, well, the definition tells you it's supposed to look like this. Yeah, it does look like that. And that's what they'll tell me. Yeah, it does look like that, but it's just backwards. It's out of order. Commutative property, which is just true. If you do use commutative property like that, it does mean the same thing, but this objectives here is telling you that you gotta use the correct format. So when adding these, you gotta make sure that you are doing it in the right order. All right, so what exactly does adding and subtracting complex numbers look like? Well, easily enough, it's just like adding normal algebra problems together where you have like terms. And like terms are things that have the same variable, that are also the same power, but that's usually not that important right now. But they have the same letter and the same power. But with imaginary numbers, it's kind of the same thing. Real parts with real parts, and the imaginary parts combined with the other imaginary parts. And again, once you see this a couple of times, it'll be pretty easy, and it'll be nothing that you're not already used to. Students should already be used to this, and you just treat I like it's any other variable. Like if I ask somebody to evaluate 5a plus 3a, you know, it would just be 8a. Same is true here. 5i plus 3i is 8i. So if two things have the same variable, you can put them together. And kind of like what I was mentioning yesterday, and I think it was one of the other lessons when we had intro to complex numbers, I said, sometimes you can combine complex numbers, because if you have like -√1, it might not seem like you can add them together, but when you convert them, like say both into I, then it works out. So like if I did something like this, it would be a little bit more confusing and it involves a lot more writing, but it's just easier to put something like this on a paper, a document, or whatever you're writing. You know, something like that's a lot easier to work with than something like this. Because this, you know, you could remember that like radicals can also be combined, but this makes way more sense. So that's one more reason why we use radicals like that. So I'm gonna go over these 3 slides, and that should be just about it for today. So I'll give you a few seconds to write this down if you're following along. I'll kind of get started, but you will have time to write this down. And before I move away from this slide, if you know, you should still have enough time to get this down in your notes. Next week, I'm gonna start doing something a little bit different with the packets. I'm gonna kind of upgrade my packets so that some of the assignments will be follow along, and you will get the answers to some of these examples and other things like that. So I'm hoping that I can increase the engagement for the videos on these. I'm constantly trying to figure out new ways to make them better, more efficient, more effective. So I might be changing my slides next week. Well, I have to now because I already submitted the papers for next week's homeworks. They're going to be a little bit bigger, but don't be scared. They are still the same number of, roughly the same number of problems on there. And like I said, we'll probably do some of them in class. So we'll probably have like a lesson with half half of the assignments on their own, so they're unique to the slides, and then some other problems, the other half may be questions from the homework. So it would pay to come to the Zoom meetings so that you could get some free answers. Okay, so let's go ahead and work on this. Now, if you are looking at I plus 6I, and you remember what I said from the last slide, shouldn't be a surprise to think that this would be 7I, because you just add the coefficients together. And if you don't see a number in front of the variable, remember that you assume that it's going to be 1. Well, you don't really assume it is 1, but we don't usually put it in there, because 1 times anything is still the same number, what we call the identity property. So according to identity property, we don't need to put a 1 in front of it. So we are done with that one. And like I said, these are not that tough. This is like a pretty short lesson, which fits perfectly because we are on early dismissal schedule today. So let's go ahead and look at this one. Now here we have 3 terms. And my first 2 are real numbers. So we can combine those. And my third one is an imaginary number, which is my only imaginary number. So I am unable to combine that with anything else. So 3 plus 4 is 7. And I also have 6I, which again, that is my only term, so I have nothing to combine it with. So it just stays the same. There's nothing else I can do with this, so we are done with it. And again, these 2 things are not like terms, so I cannot combine them. It will not become, say, 13I or something like that. They're not the same, so I can't put them together. Now I have a negative 8I and a negative 7I. Now with problems like this, in my opinion, it kind of helps to think of them as 2 separate terms, and they are both negative. So negative 8 and negative 7. Because sometimes I do get students that get confused. They're like, oh man, if I'm subtracting it, does that mean I add it? Or the other common one I get is, ooh, if I have 2 negative numbers, they make a positive. Now that's not true in all cases. It is true in some cases, but in this case, we're combining these 2 terms. So you think of it like 2 bad things happening. You know, if you stub your toe and you lose $5. You know, they don't cancel each other out. You now have 2 problems. You are now short $5 and you have a stub toe. So when you have 2 negatives like this, it will become a bigger negative. So in this case here, I have negative 15I. Ooh, that's a really good 90-degree angle on that. And that's all we can do with that one. All right, now for this next one here, I have, again, elements that are real terms, and I have imaginary terms. So I'm going to go ahead and combine them. They're also not all together, so I just drew some lines to show you where these numbers are coming from. So looking at my green line here, I have 2 real numbers, negative 4 and negative 1. Combine those, and again, don't forget, negative and negative means bigger negative when you add them. Negative and another negative, same thing. 2 negatives, when you combine them, make a bigger negative. And make sure you put them in the right order too. So don't put something like negative 9I minus 5, because again, technically it's right, but technically it's wrong. Because again, one of the objectives is to put the answer in the correct format, the correct order. Okay, so that's it for this one. We got about 6 more to go, and then you should have everything you need to complete the assignment. Okay, moving on. Okay, now with this one, we have a lot of numbers. We have a lot of stuff going on. Especially with those first 2. I looked over the homework and I don't think there are any problems that are that bad. There are some problems that are similar, but sometimes when we're going over things in class, it's usually a little bit better to do something a little bit tougher, all right? It's got to be a little bit tougher than what you're used to. So that way, when you do get to the homework, the homework is not as tough as you might have thought it would be, all right? So it's just like, say, training a fireman, all right? A fireman has to be able to carry, I don't know how much, like say, let's just say 200 pounds. He has to be able to carry 200 pounds up 5 stairs 10 times. Is he gonna do that in real life? No. But if he can do that, then he can easily, you know, go up a 3-story building one time and not be tired. Okay, so let's go ahead and start this number 5 problem here. All right, so I have a lot of things going on. Now this is an expression, it is not an equation. Remember, equations have equal signs, expressions don't have equal signs. So I know a lot of times people call everything an equation, but this is not an equation. But nonetheless, we still have to simplify it. We have to get this in as simplest form as possible. You still follow your order of operations. So parentheses are the first things you do. Now with with most of these examples, we have a negative group. So there's a lot of stuff going on here, but right now I want to call to your attention this thing here. This thing is the trickiest thing that I usually see on assignments. Because I'll kind of show you what goes wrong, and let's see if you can spot what went wrong. So we evaluated the parenthesis. We got rid of it because that is the first thing you do when you simplify or you solve. You got to get rid of those parentheses because you can't work through them. You have to get rid of them. Okay, you see it yet? All right, I'm going to show you the right answer now. The 3 is supposed to be positive, not negative. Say what? The reason that is, and again, when I'm looking through homeworks and I see something like that, that's the first thing I usually see, and I get it a lot from the homeworks for many years, for as long as I've been here. That's one of the things that happens. Now remember, when you have a parenthesis, it's like distributive property. You're supposed to give things to those numbers. So we're going to distribute this negative. And you're probably thinking, wait, why? Why do we distribute the negative? It's not a number. Oh, but it is a number. If you remember from the previous lesson, we treat this negative, it's a negative all by itself, it's negative 32, but we treat it like a number. And we do the same thing here. This negative is treated like a number because, okay, so focus on just this little area I'm talking about with the parenthesis. What we are saying is subtract the negative 5 and subtract the negative 3i. We are subtracting this group. Now, I did mention on the last slide that we have double negatives, right? If you have 2 negatives that are combining, like adding or subtracting, they will make a bigger negative. In multiplication, those negatives will undo each other. So this is take away, right? Because subtraction or minus means take away. Take away negative 5. So if you owe somebody $5 and they forget, ooh, which reminds me, if you owe somebody $5 and they forgot, you got free $5. So it's like adding $5 to your pocket. So I sometimes get that question every now and then. Why is multiplying 2 negatives going to be a positive? Because that's what it means. That, you know, numbers, they kind of tell a story. They show something that's happening. All right, now that was a long explanation, but let's go ahead and continue simplifying this. So let's go. I'm going to just sort of go down the line and start with our real numbers. It looks like I only have 2 real numbers. So this is like 5 minus 3. 5 minus 3 is 2. And now I have a whole bunch of I variables. So 6 plus 3, I'm just going to go left to right. 6 plus 3 is 9. 9 minus 8 is 1. So I have 1i. Okay, 1i like that I, not this I. And there we go. So we got 2 minus I. And again, we could put 1i in there, like the number 1, then I, but we don't really need to. And it's always a good habit to just sort of leave those off. That's like if you go to college or if you become a mathematician or if you ever use math in real life, usually you don't say that. Like if I say I saw a bird, you know, I could say I saw a bird, or I could say I saw one bird, and they mean the same thing. All right, this one does not have parentheses, so this one should go by a lot faster. So we just start with our real numbers, 1, 2, 3. So I got 3 numbers. Looks like a bird. I saw a bird. 3 plus 8 is 11. 11 minus 7 is 4. And I also have this imaginary part here, so I have 2 numbers for that. So 3 minus 2. 3 minus 2 is 1, but again, we have a variable, so I'm just going to leave that variable off. And there we go. Like I said, that one was a lot easier. I didn't have to explain parentheses or anything like that. But we got some more parentheses down here. Now, before we start this one, anytime you see a group of parentheses, be careful, because sometimes I'll get students who will look at something like this, where there's an obvious plus sign in the middle, and then they will use FOIL. They'll start multiplying first numbers, outside numbers, inside, and then last numbers. No, 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 no. Be careful with what you're seeing, because this is adding, right? We're adding this group to this group. I'm putting those two groups together. Now, in this case, since I'm adding everything together, I don't really need to do anything to get rid of the variable, the operation in the middle, or the parentheses, because we got to get rid of those parentheses first. So this first one here, this parenthesis actually isn't doing anything. And I'm adding this, so I'm adding the 3, and I'm adding the 2i. So I'm going to add the 2i here. So again, we're adding the 3 and adding the 2i. To a lot of people, this looks like nothing's going on. It looks like just regular old number doing what they do. But that plus is actually doing something. Okay, now we combine our like terms, 4 and 3. So we get 7. And 2 minus 1. Wait a minute. No, we need plus I. And again, don't forget these pluses in the middle. And I know this looks like multiplication, but it's not multiplication. There we go, that's more like it. Looks like all the examples on this page have 1i. I don't know, just something I noticed. Now with this one here, with number 8, this is a tricky one because we run into the same problem we saw from number 5, and that is there is a negative in front of a group, a parenthesis. So again, this group minus this group. When we minus this group, so this first one stays the same, nothing different is happening with it. So again, we are minusing the 1, and we are minusing the -5. Now, this would actually look like -1 minus -5i. But I think by now, most students in 11th grade would probably know the shortcut of if you have 2 negatives, it just makes it positive. So I'm going to kind of skip that now. Now, this one also has a little bit of something that's weird. I shouldn't say weird, I should say different. If you remember from yesterday's lesson, I said sometimes real numbers can become imaginary, and imaginaries can become real. So a complex number, like in our case right here, if you look what's going to happen, this complex number becomes a real number. Complex number becomes a real number just like this. So 7 minus 1 is 6. But if I look at the imaginary parts, 5i minus 5i. We have 0i now, it's gone. So since it has 0, I don't need to mention it. If I didn't see a bird today, I don't even need to bring it up. So this imaginary complex number became a real number. And that's why we use the I, well, one of the reasons why we use the I instead of just leaving it as root -1. So that's 2 reasons we covered today. One, because it's easier to add because you just treat it like variables. And 2, because sometimes you can do things that make them become real or change the type of number they are. So again, if I had just stopped with a root -1 and said this problem cannot be solved, I'd be wrong, because if I kept going with this one, this is not really a solving problem, but just as an example, if there was an equation with something like this, then we can solve it. Okay. Now this will be the last one for today. This one has a few of the same things that we saw in the last one. But again, today, I just want you to really walk away with the point of watching out for these negatives in front of groups. All right, so everything else from this lesson, you just take from your normal algebra skills, right? So by the time you're in Algebra 1, or I should say by the end of Algebra 1, you should have mastered most of these techniques, most of these rules, most of these things you got to watch out for. But this is the one thing with the negative group that I see quite oftentimes, even in upper levels and even into the college level, I see that all the time where people forget that. Oh no, my internet. Okay, I'm getting a note on my screen. I don't know if you can see it, but it says internet connection is unstable. So I don't know if I'm going to lose anybody at this point. So let me go ahead and get started on this. So again, we are subtracting the -2 and we are subtracting the -9. I'm sorry, we're subtracting 9i, not -9i. So again, be careful. +2, getting rid of all these parentheses. Okay, now in this case here, I'm going to simplify this part here. Instead of saying plus -8, I'm just going to leave it as -8, which is just -8. And again, when you have a plus sign in front of the group, that doesn't really change anything. It just leaves it largely the same. Oopsie, losing people. There we go. And again, I'm going to double check this part. So we reverse the sign on the negative, so it's now positive, and the positive is now negative. So this one we did right. And these, again, when you have a plus in front of the group, that doesn't change anything. I'm adding that whole group. Now I can go ahead and add my real number. So 6 plus 2 is 8 minus 8. So I end up with 0 as my real number. So in this case now, my complex number has become purely imaginary number. Become completely an imaginary number, I think. I don't know. English can be a weird language sometimes. Anyway, so I have no real number, so I have, well, 4 is my positive, so I can think of this as 4 minus 9, which would be -5i. Oopsie, looks like my internet's getting bad. All right, last one. All right, so for this one again, I'm just going to go down the line. 5 minus 3 minus 2i minus 3 plus I. Okay, did you catch that? Now be careful, because this, again, this is usually what I see. students will give the first term the negative, but they will not give it to the second one. And when that happens, you gotta check it. Again, both of these numbers have to change sign. So be careful with that. Sometimes during normal classes, I'll make a mistake like this and see who catches it. Because that's part of what you have to do. You have to look around, make sure you're doing things the right way. Anyway, let's go ahead and combine our like terms. So 5 minus 3 is 2. So 2 minus 3. All right, so I'm minusing a bigger number than I started with. So 2 minus 3 is going to be negative 1. And here I have negative 2i and negative 1i. So that would make negative 3i. Okay, now, like I said, today is a half a day, so it's going to be a bit of a shorter lesson. I think I got started a bit late, so I'm not sure exactly how long this video is going to be, but hopefully that will be enough to get through this lesson, and that will be it for today. So as always, I'll go ahead and leave the end open for a few questions until everybody's done. If there are no further questions, I guess that will be it for today, and I will see you guys tomorrow where we will resume regular normal class hours. And again, same link, same time, so don't I am having some people getting confused and losing the links. So it's the same link each day. So bookmark your links on the Zoom. All right, so bookmark them so that way you can easily find it on your phone or your computer. Anyway, thanks for stopping by. I will see you next time.